Hello, everyone. Good morning. Welcome to the Subina TV, our channel dedicated to discuss the most relevant subjects for the Brazilian shipbuilding and offshore industry. Welcome to our second workshop on offshore wind and ocean energy. Once more on a webinar format due to the pandemic restrictions. Today, we will address the technical, regulatory, and environmental aspects related to the use of renewable sources in the ocean, including offshore wind and wave energy, among others. We intend to promote a debate about the global and national scenario of the sector of renewable energy in the ocean, with the participation of representatives from the regulatory agency, companies in the energy sector, and international research and development institutions. For who doesn't know us, SOBINA is the Brazilian Society of Marine Engineering Naval Architects. Created in 1962, we are a totally non-profit organization which aims to promote ocean engineering and offshore engineering in Brazil by disseminating knowledge for more than 59 years now. We are a forum to discuss technology and innovation to be used by the Brazilian industry. Please note that we in SOBINA, we are not only composed by marine engineers and naval architects, but we are a technical society to all of those individuals and companies working in the sector with the desire to participate in the technical development of our industry. So, you also can participate. You can make the difference. If you are interested, please join us. In SOBINA, we have different technical committees trying to map the most relevant challenges for our industry, and you can be a part of this effort. Now, I would like to thank all of those who made this event possible. Thanks to our technical director, Professor Teodoro Antuneto from COPE UFG. To all of our technical committee, which was responsible to organize this event, and special to its coordinators. Professor Sejen Stephen from COPE UFRG, Professor Milad Shadman from COPE UFRG, of the group GERO, Group of Renewable Energy, Ocean Renewable Energy, sorry, and Professor Alexandre Simos from the University of São Paulo. Thanks, of course, to our organization team and to all speakers who voluntarily will make this event so special. Of course, I cannot forget to thank to our sponsors who made this event feasible. Our master sponsor, Ocean Pact, and our silver sponsors, DNV, Det Not Veritas, and BV, the Bureau Veritas. Before we start our event, we will show a short video from Ocean Pact.
The oceans are fundamental for our planet's survival. They regulate the climate, process nutrients, and provide a wide range of ecosystem services, including natural resources, energy, and food and jobs that benefit millions of people. It is by the seas and for the seas that Ocean Pact exists. As of 2019, over 2,000 kilometers of Brazil's coastline were contaminated by crude oil. Ocean Pact went to the area to assist and help mitigate the problem. Just like we did 10 years ago after the explosion of the Deepwater Horizon platform in the Gulf of Mexico. To truly understand our magnificent planet requires commitment, determination, and love for the oceans. We always act safely and we respect the environment as a fundamental ethical pillar. OceanPact operates in 3 key segments: environment, subsea operations, and logistics and engineering. And we are constantly investing in innovation. OceanPact only exists because of the strength of our 1,600 employees, 190 of whom are oceanographers, biologists, or engineers. Our team operates a fleet of 24 offshore vessels and 41 port vessels. OceanPact, reference in knowledge and services at sea.
Okay. Now, I would like to invite the coordinator of our technical committee, Professor Session01, to start our webinar. I wish to you all a very productive webinar and a very nice day. It's all yours, Session. Good luck.
Thank you very much, Portela, for the opening and presentations. And good day for all. And today we have 2 sections. In fact, it's a long morning. In the first section, we have 6 speakers. And the second session, we have another 6 speakers. In the second session, my colleague, Professor Alexandre Simos, will moderate the section. And I will ask now the first speaker, Robert Galinsky from DNV, for the presentation. His presentation has the title Marine Supply Chain Support to Offshore Wind Industry. Robert is the Offshore Wind Director for the Americas in DNV. He has been involved in offshore industry in Europe for over a decade and directed projects for offshore wind farms in UK, Netherlands, and Belgium. Prior to his move to Houston, he oversees the North Sea operations for DNV based on Aberdeen. In his current role, Robert holds responsibility for management of operations and strategy related to DNV's classification business for offshore developments in Americas. Please, Robert.
Thank you very much for that introduction. It's great to be here. I hope you can see my presentation now, Serge.
Please.
Okay, I just want to address a few things that are quite important in the industry. You know, we're seeing a true revolution in how offshore wind is developing, and the global demand for green energy is growing exponentially. Offshore wind is certainly one of the main sources to obtain clean energy, but with the eyes on technology, increased capability of turbines, and ever-growing expectations of quicker delivery, then we have to ask ourselves, can the supply chain keep up? So I want to dive a little bit into the aspects of the supply chain and the service that services the offshore wind industry, and touch on how best we can prepare to take the offshore wind transition into the level that we desire. But before I jump into that, I want to give you a very brief introduction of DNV and what we do. So in DNV, we've been working with renewables for decades. In the offshore wind sector, we've built a reputation of a trusted partner to tackle global transformations. We've been involved in offshore wind developments for over 30 years and have essentially been involved in every offshore wind project globally in some form. When it comes to vessels engaged with offshore wind, DNV has the majority of class in major vessel categories, including SOVs and wind turbine installation vessels. Globally, DNV has over 2,000 energy experts working in the space, and we have unique experience spanning from the full life cycle of the offshore wind projects, from feasibility, development, engineering, construction to operation. We have a unique position to be able to interface with all levels of supply chain, which gives us a wide exposure to the issues in the industry, which we can then leverage positively and impact the development of ocean space technologies. Part of our commitment to the industry is the annual Energy Transition Outlook, which we publish every year, presenting the energy trends that will affect the world in the near future. And the last version of it was just published now on September 1st. So if you are interested in having a look at that report, I will provide a link at the end of my presentation. But I want to kind of set the scene with a few slides to illustrate the potential of offshore wind before we jump into the supply chain discussions. So, we are approaching a future where the world will need less energy, even with the global population increasing and the economy growing. By 2030, we estimate that energy use peaks, and then from that moment on, we'll see humanity using less energy. Large energy efficiency improvement in all sectors and accelerated electrification with electricity dominated by renewables will be the primary source of energy, and the supply will peak in 2032. Fossil fuels will reduce its share of the energy mix from 81% today to about 50% by 2050. As you can see from the chart, the renewables, in particular solar and wind, will be playing an important part moving forward. Electrification is fundamental to the ongoing energy transition, and electricity demand will more than double between now and 2050. Share of variable renewable energy sources in the power mix will grow from 8% today to about 70% in 2050. Grid infrastructure will need to improve to ensure it can handle the high demand that we foresee is coming. Since electrification is a major theme in the ongoing transition, what you see here is a massive shift in the power mix. We expect that the electricity as an energy carrier to more than double over the next 3 decades, with dramatic changes in the electricity mix as solar and wind take over from coal. By mid-century, 36% of the world's electricity will be supplied by solar and another 33% by wind, combining into a 70% mix. And then fossil fuels will account for just 13% of the power generation. So combining that with combining floating and the fixed wind projects, they will certainly chase the onshore wind developments, and they will scale to comparable levels by mid-century. Lower energy prices for renewables give room for gas-fired electricity to stay longer in the system. We estimate that gas power generation will decline from 35 to about 29% by 2050. Solar and wind will be the most competitive options in most regions, even without government subsidies in place. And over time, likely by 2030, it will also be cheaper than existing coal and gas power. This growth pattern, of course, assumes that the investment is made to ensure success. There's a firm commitment from governments and from major developers, but also the rest of the supply chain to make this happen. There are, however, several areas where we need to focus on to succeed. Globally, the offshore wind energy industry installed about 5.5 gigawatts of capacity last year alone, mainly in China and in Europe. And the pipeline for the global capacity right now is about 307 gigawatts. When we look at the floating wind in isolation, you'll see that the power capacity has tripled in the last year, and now the overall segment grows from 7 gigawatts to about 26 gigawatts currently. Size of the turbines is constantly growing, with the next range expected to be between 12 and 15 megawatts, soon to be available in as early as next year into a couple years. The advancement in technologies has propelled the industry into significant growth, but with the leap comes some challenges. Focusing on capex, for example, is key to success. We are seeing that some Asian projects are opting more on controlling capex with lesser capacity in the projects as a trade-off. So you'll likely see different strategies in different parts of the world when it comes to managing these projects moving forward. Floating wind will actually define a lot of the strategies for the future. So I want to give you a little bit of substance. So the floating wind turbines, they give access to far more wind resources over deeper water, at least 4 times as much ocean space compared to the bottom fixed wind. So this gives an increased flexibility in site selection, including possibility to take advantage of areas with higher wind speeds, areas with lower social and environmental impacts, and so on. So next 5 years, we expect to see significant technology development in floating wind to reduce costs, scale, and increase applicability. To put this into perspective, floating wind will contribute 250 gigawatts. That accounts for about 2% of the world's electricity generation by 2050. This corresponds to a development of more than 3,000 times the size of Hywind Tampen, which is the world's largest floating offshore wind farm currently under construction in Norway. Floating wind can bring clean energy to coastal communities, previously unserved by wind power. For example, some of the mega cities in Asia Pacific. But there's also other aspects that create interest in floating wind. Opportunities, for example, for oil and gas and maritime players to transfer their skills, vessels and yards into new growing industry, and the opportunity for using floating wind to power oil and gas installations to reduce CO2 footprint, which we're already seeing. So when considering the challenges of developing and building offshore wind projects, it's critical to have a holistic view of the complexity of these projects. First, these are offshore projects. We have to remember that. So the weather and site conditions create a major challenge. And increasingly, projects are becoming larger and moving further offshore into deeper waters. Second, technology is continually evolving with the drive towards increased reliability and maximizing energy outputs. And this evolving technology impacts the requirements for ports and vessels and other infrastructure and equipment. So layering on top of this are complex challenges with regulations, uncertainty and competition in the power markets, and challenges with connecting projects to the grid. Connected to all of this are supply chain challenges that are critical to successfully managing the development of offshore wind projects, particularly in the face of continuous pressure to reduce cost and manage risks. As an example, global supply of installation vessels needs to accelerate to meet the demand, as currently there are very few vessels that can handle installation of the larger turbines. Developers are commissioning new installation vessels, but since the lack of supply is really a global issue, we will see new building activity in places where these vessels were never built. North America is being a prime example where that's actually happening. So this creates challenges with the ability of the shipyards and manufacturing facilities to support these projects, and in turn, the supply chain has to mature far quicker than expected. And as a result, this uncertainty regarding the ability of the global fleet to handle planned installations, in terms of capacity, comes into question, even for projects that are up to mid-2020s. So really, it's highly reliant on how quickly the supply chain can keep up to be able to materialize these projects. A shortage of installation vessels could lead to increased wind energy costs, for example, and higher vessel charter rates or project delays. So you know, that can have a major impact overall. Installation vessels are, of course, only one of the types. We need to look at every other support vessel that's out there as well to really appreciate the size of the supply chain itself. Tugs, barges, survey vessels, cable layers, heavy lifts, rock dumpers, CTVs, and SOVs are all part of the picture, and each needs a separate look and has separate pricing model, delivery model, and so on. In some cases, the industry will be able to repurpose some existing vessels. However, with environmental targets in mind, this cannot be applied to all ships, and therefore alternative fuels will be very key for chartering vessels to service the wind farms in the future. Developers expect it, the world expects it, and it's certainly a needed connection with the ultimate vision of a cleaner future. So to illustrate the technological advances that can drive infrastructure development, I want to briefly show you one of the offshore charging solution concepts for wind farms. This offshore charging point is a concept under development currently. It aims to enable idle vessels to turn off their engines and replace the fossil fuel burning with renewable energy when they're idle. Maersk Supply Service has agreed with Ørsted to pilot a buoy at their offshore wind farm, and the test is set to take place sometime this year. And upon successful testing and concept approval, this will be offered to congested ports and energy companies for vessels that are idle. Another key aspect is the port infrastructure. The development and timing is key here, and could turn into a challenge if not handled correctly. Some ports may struggle to keep up with the growing size of these projects, and this will push the current infrastructure to its limits. Heavy lift operations, for example, storage space, hook height limitations for lifting appliances are all areas that need attention. Ports are in the center of the offshore wind industry. All the transportation goes through them. They're the base for the O&M activities for offshore wind farms, and they are the crossroads for the entire supply chain. So a huge expansion is likely. It's predicted across the world, with Europe, Asia, and America leading the way. And the ambitious targets set cannot be delivered without having huge investments in port infrastructure. Heavy loading quaysides, deep berths, hydrogen infrastructure, and of course space are going to be main focus areas for investors and for financiers as well when it comes to planning of expansion. The potential for ports and harbors is in key locations, needs to be assessed in terms of fabrication, assembly, integration, staging, manufacturing, maintenance, and service of support vessels. So we'll likely see some key ports completely repurposing what they do now to service this industry. Because ports are so crucial in this ecosystem, they will also be crucial in decarbonization. Over the next decade, ports will likely play a key role in upscaling renewable hydrogen infrastructure. They're a natural location for electrolyzers, for example, and suitability assessments at ports are already being conducted. So renewable hydrogen produced in ports can be stored locally and consumed within the local business ecosystems. It can also be used as a fuel for transportation or processed to obtain ammonia for use in marine shipping. The development of port infrastructure is commonly a matter of local, regional, and national authorities. So the strategy for these will heavily depend on what position those governments take, and it will largely shape the direction of the developments in individual countries. Optimizing what was done offshore versus import will take a big impact on CapEx. And we talked a little bit about CapEx and how important it is. So developers can save time on installation if ports provide support. Moving manufacturing shoreside reduces cost and increases safety to personnel compared to doing it offshore. In case of floating wind, mooring pre-lay can reduce commissioning offshore. Government subsidies, for example, will likely be required, and work needs to start soon to ensure the supply chain can keep up. But overall, I think we shouldn't really try to reinvent the wheel. There is a mature supply chain in existence already, and served many industries in the past, mainly shipping and oil and gas production. That certainly can be reutilized as long as it adjusts to the expectations of key stakeholders. The preference for many governments is to promote local capabilities and boost local competence and resources. With the kind of commitment that we're seeing in the offshore wind industry, we are likely to see major investment being directed at local businesses to support. Okay, I will stop here. Many thanks for listening. I'm happy to take some questions if there are any. Thank you so much.
Thank you, Robert, for your presentation. I can see here some questions, but first of all, I would like to ask you one quick question about offshore hydrogen production.
Mm-hmm.
How you're feeling about this development, and which countries are in the front running of these projects?
I mean, first of all, I think the green hydrogen production is likely going to be the future. The key really is in maturing the infrastructure associated with it to be able to take full potential of what it can do. I have no doubt that being able to produce hydrogen as one of the main kind of power sources in the future is going to be the way forward. And Europe certainly is looking at it. There's a lot of government support, a lot of subsidies that are currently in place to develop this technology. I think Asia is also certainly a market to look at. So those two are key geographical locations where I think this will take off.
Okay, Robert. I think we are running for time. Thank you very much for your presentation, and I hope you join us the next events. Thank you very much.
Thank you. Great to be here. Appreciate it.
Okay, now I would like to invite Professor Hideyuki Suzuki from University of Tokyo. Professor Suzuki has Doctor of Engineering at the University of Tokyo, Department of Naval Architecture. He has been working in different departments from the university, Department of Environment and Ocean Engineering, Department of Ocean Technology Policy and Environment. He has been a research associated at California at Berkeley, University of California at Berkeley, and he is presently Vice President of Japan Society of Naval Architects and Ocean Engineers. Please, Professor Suzuki.
Okay, thank you for the introduction. So my presentation is speed talk is research and development of and the use of offshore wind energy by a wind turbine in Japan. So this is the contents of my talk. First, I introduce the latest development in Japan and the concept development and the feasibility studies and the technology demonstration projects and the development of rules and analysis code. And finally, challenge for green innovations. Okay, latest developments. So big events we had last year in Japan is announcement of Japanese government. It says that we will establish a carbon neutral society by 2050s. And also Japanese government announced that set a goal. It said that we will introduce 30 to 45 gigawatts of offshore wind by 2040s. And we will expect that maybe around the 25 gigawatt was provided by floating offshore wind turbine, floating offshore concept. So, and also Japanese government established the Green Innovation Fund to accelerate the technology developments. It's around 18 billion US dollars. It was established in NATO, and 1.1 billion is assigned to the offshore wind, and 0.9 billion for floating concept. So now many Japanese companies are much more interested in the floating offshore wind turbine than ever. And the technology demonstration projects technology demonstrations. So we had until today that we did some technology demonstration project, and based on the concept development and the feasibility studies. One is a Fukushima project, floating wind farm concept, and comprised of 1 spar and 2 semi-sub. And the Goto project, semi-subs are not in a spar type. And the Kitakyushu project, it's now going on, and the barge type. And the outcomes and identified challenges. So actually, technology readiness levels of the concepts are advanced. But we need to reduce the cost. It's a key challenges, and probably immediate capex goal will be 4,500 US dollars per kilowatt. And also, wind condition in Japan is not so good, so we need to develop a technology for low wind speed conditions. And I'll introduce some concept developments and feasibility studies in 2000 to 2010. So firstly, I introduced the potential resources of wind in Japan. So now electricity power generation capacity in Japan is 260 gigawatts. And compare these numbers, the potential resources on land wind is 150 gigawatts. And the immediate goal will be 23 to or 25 gigawatts. And if we look at the offshore wind, the potential resources is 10 times larger, very huge. But under the technology development phase, the immediate goal will be 13 or 20 gigawatts. But we had huge deployable sea areas. But coastal waters suitable for offshore wind energy development are very deep, mostly deeper in around Japan. So, for example, this orange colored area very close to the shore, but it's already several 100-meter deep. So we strongly recognize the necessity to develop the floating offshore wind turbine concept in the early stage, very early stages. And so this is a concept all developed in Japan around the year 2000s. And the technology demonstration project from 2011 to the present. First technology demonstration project is supported by a Ministry of Environment. The mission of the Ministry of Environment is to develop the technical option for carbon reduction, greenhouse gas reduction. And so the project started 2010, and they installed spar-type floating wind turbines in year 2013. And this is a spar-type and the hybrid type, and the upper part is steel and the lower part is pressed concrete. It was installed offshore Kawashima Island. Here is Kyushu Island. Here is Goto Island, and we have a very small Kawashima Island here. And from 2 kilometers from Kawashima Island, this floating offshore wind turbine was installed. And now that this concept is going into the commercial phase, and cable laying already started, and the total capacity is 22 megawatts, and the operation will start beginning of 2024. Okay, so and another technology demonstration was supported by Ministry of Economy, Trade and Industries. So we had a big earthquake in 2011, and it triggered the accident of a nuclear power station located in Fukushima. And at the present, only a 9 nuclear power plant is operating. Another out of 59. So 50 nuclear power plant is now under the safety reviews, and all stopped. And so we needed to, this ministry considered that we needed to accelerate the development of renewable energies. So objectives of this project is rehabilitation of Fukushima regions, and technology demonstration of wind farm technologies. So this wind farm is comprised of 1 floating substation and 2 megawatt, 5 megawatt, and 7 megawatt floating offshore wind turbine. And so this is an experiment site, and this is a destroyed nuclear power plant, and this is a navigation restricted area just after the accident. And outside of this area, experiment site was set like this. And this is a photo of the installed facilities. So this is the floating substructures, substations, and 2 megawatt semi-subtype floating offshore wind turbine, and this is also a 7 megawatt semi-subtype, and this is a spar type 5 megawatt spar type floating offshore wind turbine. And the result of Fukushima project, from an experience of operation and maintenance, we understand that the availability of the floating offshore wind turbine is more than 95%. And capacity factor is around 30%, in this case 32.9%. capacity factors. And this is a numbers we had from the experiment and capacity factor like this. And we also experience a fast marine growth. This can be a big problem. And for cost, basically we consider that basically analysis by carbon thrust. It was done in 2015. Is basically applicable to the development in Japan. So in the prototype phase, this is a result by carbon thrust. But in Japan, this cost of prototype is much higher than this. But now the company is making a lot of effort, and it becoming capex becoming smaller, and then we hope that it will be $4,500 US something. And so, looking at these technology demonstration projects, NEDO initiated another technology demonstration project. Target is challenge for cost reduction. And so we developed installation technologies and mooring system for shallow waters, 50 to 100 meters. And so this is the target of the present demonstration by NEDO. So this barge type floating offshore wind turbine was installed offshore Kitakyushu. So we invited the low-cost concept from France, and so target is cost reduction. And we previous technology demonstration was done by all domestic technologies, but this one we invited concept from all over the world. And this is a mooring system and the cabling system like this. And another supporting development is rules and analysis codes. So technical standard of floating offshore wind turbine is made by created by Ministry of Land, Infrastructure, Transport, and Tourism. And this standard was created in 2012, and based on this standard, Japanese Classification Society (NK) created a design guideline of floating offshore wind turbine almost 9 years before. And now it's a bit old now, so this guideline will be updated soon. And also, we developed, this is the example, we developed the rotor floater mooring control coupled response analysis code for analyzing the floating offshore wind turbine. This is an example we developed and with NK classification societies. And challenge for green innovations. So anyway, capex reduction is a key for commercializing the offshore wind turbines. And so key items which will contribute to reduce the cost is one is a larger wind turbine, we think, and the mass production for mass production, and right and easy to construct concept for mooring system and floater concept, and also efficient transportation and installation is key for reduction of capex way we think. And this is a reduction of capex. And also, in addition to the reduction of capex, we need to increase power production. So wind condition in Japan is not so good as in North Sea. So we need to install wind turbine at the higher wind speed area. So it means that the site location is offshore of coast of northeast Japan. And also we need to catch the high-speed wind at a higher altitude. So it means that the larger wind turbine. And also we need a technology to capture the energy at lower wind speeds. So development of blade is one of the key development. And also capex, OPEX reductions. So reliability must be higher, and accessibility to the floating offshore window at the offshore need to be improved, and prevention of marine growth, efficient inspection, and also maybe failure prediction will be necessary. So that's an overview of the current situation in Japan. Thank you.
Thank you, Professor Suzuki. Very nice presentation. I think okay. I'd like to ask you a question about the costs. In Japan, most of the developments must be floating turbines. And these floating turbines, which kind of design you think will be more effective? I mean, semi-submersibles or spars, which ones you think will be the best solution?
Okay, that's a frequently asked question. But condition of waters is different from place to place. Some place is deeper and maybe suitable for the spar type, and some area is very calm, maybe suitable for the barge type concept. And our Pacific side wave is very harsh, and so semi-submersible type we need to install. And so depending on the site conditions, we need to choose the type. And also at the present, we started to install the bottom-mounted type. But soon we move to the floating ocean wind turbine where we expect. Yeah.
Okay, thank you. We have time for one more question. Maybe Professor Alexandre can intervene.
Yeah. Thank you, Professor Suzuki. It's a very nice presentation. I'll ask you again about the capex, which of course for the floating wind turbine is a key subject, no? Reduction of capex. But you have listed a few drives that you see the more important for reducing the capex. But from your experience in Japan, from these possibilities we have for reducing it, which one do you think is more appealing, let's say, or more will have a bigger impact in the near future?
For cost reduction?
Yes.
Okay. At present, looking at the technology demonstration project, construction time offshore is very long. and cost of facilities for install the running line and such a things is very huge. So short time construction or towing is very effective, I think.
Okay, thank you.
Okay, thank you. Unfortunately, we have no time for more questions. But Professor Suzuki, there is 2 questions in the Q&A, one related to VIV and the other one related with Japan wind speed. If you could please answer them in Q&A. Thank you very much for your presentation.
Okay, thank you.
And comments. Very nice to meet you again.
Okay, very, very nice. Yeah.
Thank you. And now I'd like to remind the audience that questions could be displayed either in the chat or Q&A. Then you can make questions. If you have time, the speaker will answer. Otherwise, they will answer you later. Now, I'd like to invite Ms. Laura Gonzalez from Scottish Power for the presentation. Laura Gonzalez has been working in renewable energy from CO2 capture to storage studies to offshore wind. She joined Scottish Power as planner for East Anglia project. Now she is working as engineering manager in the new business and development towards net zero target in countries with emerging regulatory regimes. Please, Lara.
Good morning, bon dia.
Bon dia.
Well, I'm Lara Gonzalez. Today I'm working in Scottish Power, that is a brand in the UK for Iberdrola Holding that also covers for Neoenergia. I'm very happy to be here. And well, today we will be speaking about why offshore wind and what's our track towards this net zero target. Yes, I'm an engineer. I'm very passionate about what we're doing together towards this global energy transition. As said, I've been working in the renewables industry since the very beginning, and I'm a big believer of this effort we're all putting towards this net zero target. So first of all, why offshore wind? Many of you will know that we have these UN Sustainable Development Goals. And since we're all part of this society, we shall contribute towards achieving those. And among others, we have this goal 13, that is the climate action. And we have to take action, urgent action to combat this climate change and its impacts. So for that, we're part of this energy transition, this decarbonization works. And we have offshore wind that opens up the sea with all these opportunities we have, from fixed to floating, from mixed technologies. And we have offshore wind that is powerful and reliable, and well, actually high wind resource. So we have to take advantage of this. Since I work for Iberdrola, I'm going to give a brief introduction about its role there. So we're fully committed in Iberdrola, in Neoenergia, in Avangrid, Scottish Power, that we have to help society to achieve the United Nations Sustainable Development Goals. And well, as a global leader in the utility sector, well, in the UK, we are a 100% renewable producer. In USA, we're the 3rd highest wind producer. And in the rest of the regions, in Europe, Brazil, APAC, we are leaders or we're targeting new opportunities. So we really believe that renewables is our future, it's our present. As specifically in the offshore business, our role, we started in this business more than 10 years ago, and it can be seen in this map that we've been involved in many countries. But since the last year and a half, well, Iberdrola has expanded significantly the offshore wind pipeline from 9 gigawatts we had in our pipeline to more than 20 as of February 21. So we're entering in new markets like Sweden, Brazil, Poland, Ireland, Japan. So it can be seen that the offshore wind momentum is impressive. It's here. We have to take this advantage to follow the trend, the market trend, the energy mix trend that we have to diversify. So we have this strategy in Iberdrola that we always try and build a hub. We're first mover in the US. We are building a mega hub in Baltic Sea with Vikinger that is already operating, and we're building a new wind farm in Baltic Eagle. So, and our plan everywhere we go is to close the circle and build a big hub with ports, supply chain, value chain, creating jobs. And that's our motto. We're also a major player in the UK in the wind industry, and also in France. Additionally, we have a broad experience onshore and offshore, and we have over 10,000 VTGs installed. We have just in offshore 600 full-time employees and a lot of in-house experience, like foundations, in-house experience for transmission assets. We're a very diverse multinational team that we're all believing in what we're doing, and that's our biggest strength. And this just covers our role in the offshore business, but how can we translate this in Brazil, and how do we do this? How do we make offshore wind a reality in Brazil? So how we do this is we plan from the very beginning, the origination phase till the evaluation phase. That is when we are already operating and reflecting on how we've done things. So from the very beginning, the origination phase is when we structure the team, we plan our business strategy based on securing a site. So we have a critical milestone, that is the seabed rights milestone. That means that we have a location permit to build a wind farm in this seabed site. So this is one of the key aspects to start building this wind farm. And after that, once we've secured the site and we have these exclusivity users, we start planning the consenting process, the permitting process, all the regulatory framework is in place. And we start building this development phase and the basic engineering concept design that will help us build this business case towards this tariff. That is the second key milestone that it's needed to make this program, this plan work. That means that the government where we're in supports our plan to build an offshore wind, to build renewable energy and diversify this electricity mix. And we will have this support scheme. That means that literally it supports and makes this project feasible. And then we would just start engineering, constructing, and commissioning this wind farm. That is our main goal, to provide electricity to all the users and cover for the demand and create value along the entire process. So from the very beginning, from the origination phase, how do we plan this wind farm? We have two main work streams. There is the development phase and the engineering phase. That means that from the development phase is just building this stakeholders relationship. That is key, because our work impacts others and we're impacted by others also. So it's key to start building these relationships. And also it's key to start understanding the permitting process. which permits and consents do we need to get granted before building anything. From the engineering phase, from the engineering part, what we do is once we have selected the site, even if we don't have this seabed rights secured, what we do is characterize the site. That means that we will know from the soil to the wind what's going on there. That means what type of soil do we have, what's the water depth, what are the currents or waves acting there, and also what's the wind speed. That is most important part. And then we plan this layout. With that, part of these engineering activities that we have to take into account is just carry out any surveys, like the geophys survey, geotech surveys. We place metocean buoy to measure wind at surface level, the current and the speeds, the wave speeds, and also floating LiDAR, where what we do is measure the wind and during a 1-year campaign. That's because the data is that accurate that we don't need a longer campaign. So that's a big asset from ours. And with that, we can build this base case based on VTGs, where following this trend that Robert Galinski was speaking about, well, we've seen this high-speed growth in terms of rotor diameter and nameplate of the VTGs. So we don't know what the future will bring to us. We're looking at 20-25 megawatts turbine. And knowing that just 10 years ago, we were speaking about just 2 megawatts, it just gives us the insight on how fast this market is growing. And yeah, as I said, we have to take this chance and grab it. Then once we select this wind turbine, or we estimate how big will it be, then we select the foundations solution, we size it. We already know the VTG, we already know the water depth and the soil conditions because we've run these surveys. We also need to know how ready is the supply chain. That also links with Robert's presentation and the port system. How will this be built, actually? And with all that, we are able to find which solution we will go for. So we have from monopiles, that is for shallow waters, to floating foundations, as Professor Suzuki was explaining. And depending on the water depth and the size of the VTG, we will be able to choose. Given the water depth we have in Brazil, the most likely solution will be monopile. So just to give you an overview of how big it can get, in 2014, we had a 5.6 meters diameter monopile. And we're now, given the size of these VTGs, we're looking at above 10 meters diameter. So this provides us a bit of a reference on how big it can get, and also can give us an insight of the challenge for the supply chain and the installation systems. But we will get there. Also, another thing we start planning from the very beginning is the innovative solutions. So just in the foundations where the market is already looking at some solutions for the crew transfer, like the get up safe. There is a hoist, like a kind of a lift that brings up the crew up to from the CTV. We're also looking at slip joints. That is a friction system that avoids or replaces the grout and the bolted connection, or even a TP-less monopile. That the TP, the transition piece, is the piece between the foundation and the tower that connects them and also hosts a lot of equipment there. So this is another innovative solution that we are all looking at. Then last part of the wind farm that we need to think about is the transmission system. So coming from the VTGs, we need to know the voltage level. It can be, now it's at 66 kV, but some suppliers are also speaking about 132 kV. So this will serve us to plan this inter-array cable layouts, that is the internal transmission system in the wind farm. Another decision that needs to be made very soon is the solution that we will be taking. That is, are we going for HVDC or HVAC? That is depending on the wind farm size, the distance to shore, the voltage level onshore and offshore. So with that, also taking into account the CapEx and the funding capacities, we are able to choose this technology. It's completely dependent on wind farm specific details. So it needs to be assessed from the very beginning because it determines the entire project. If we go for HVAC, there's another solution that we need to take into account. That is, are we going for an OTM or an offshore substation standard model? That means that if we go for an OTM, it's offshore transmission transformer module. There is a new concept, well, new. It's a concept that is much more compact, it's smaller, cheaper, and it can be installed easier than the standard model we know. But on another side, it isn't as redundant as the offshore substation as we know it. But for all of these decisions, the key aspect is that we need an early relationship with the local transmission operator. That means that we need to know what is the voltage level that we have onshore, what is the onshore substation that we have available as of today, and we will have when we will be connecting to them. Is there any grid connection agreement in place? When will it be? Is it needed for the auction? So there's a lot of points that needs to be discussed from the beginning to have a smooth connection to the system, because that's the end target, to provide electricity to the users and provide reliability and, well, a green energy. That's part of the targets, right? And just to finish, as a conclusion, I want everybody to remember the main challenges we're facing in emerging countries, like with emerging regimes like Brazil. That is, we need regulation in place to have security that this is feasible. That means that we need a regulation that plans the maritime space. We need a regulation that supports the ports system and that explains how this can be organized, how other users can interact with us. And well, as far as we know, it's expected by the end of this year, so that's very good news. Another challenge we have is the competition. I mean, it was already said in one of the comments in the chat that there's about 42 gigawatts being planned in Brazil. So a competition process will help everybody to be able to build something there, to contribute with the local communities, to create jobs, to cover for the demand. So this framework that I was speaking about, this competition is needed for everybody to create value for Brazil. And as part of that, this support scheme I was speaking about, an auction, some tariff that can help us build a viable project. Like, I think that this month there will be an auction for biomass adjusted to 600 reais. That tariff would be amazing for offshore wind to make it feasible for Brazil. But still, it's ongoing, right? And also another challenge is this energy mixed diversification and cover for the demand I was already speaking about. And the last one is the transmission system. So we need a reliable and robust transmission system where we can connect when we won't face problems and we won't create. And we need a proper transmission system and onshore substation that support us. So that's all from my side. I don't know if you have any other questions. And thank you for attending this and creating this traction to make Brazil offshore wind happen.
Thank you very much, Lara, for your very interesting presentation. I have a question related to ocean space. It's a big discussion here in Brazil about the management of the ocean space. This is for your presentation. It seems that this is very important issue for the definition of investments by the companies. In addition, I'd like you to comment about this, the ocean space, and how it could help companies to invest in Brazil. The other question, it's about monopiles versus floating. In my view, in Brazil, we have very shallow waters with possibility of implementing wind farms, but this could represent a very high environment impact in the next decade, because you have a lot of piles installed, and decommissioning could be a big issue in the future. How you see these two aspects, two questions?
Yeah, I will start with the Maritime Spatial Plan. This is key, as in land. We need to organize the space because everybody wants to use it, and we want to use it properly. So I think this is a demand, a requirement that we need to ask the government to, this needs to be organized, because we have environmental issues like the coral reefs, we have port service areas, we have oil and gas rigs, we have offshore wind users, and then all the maritime fishery, transportation, even radars from the airports. So this cannot be like the first wave that arrives, it can take it. It shouldn't be like that, because otherwise, if you go anywhere in Sao Paulo and find a land, you just take it. It doesn't work like that. That's why we're demanding this Maritime Spatial Plan or some regulation towards the locations, because we need some order. That's the main conclusion. And then speaking about the environmental impact, part of this already in place frame regulation is that we need to carry out an environmental impact assessment. And at least in Neoenergia, we're already working towards that, because yes, as I said, there are other users that might be impacted. It can be the coral reefs, it can be the transportation business, it can be other wind farm users, other offshore wind farm investors. So there's an impact, but also there's a positive impact in the offshore wind. So that means that there can be mitigation measures for transportation routes, for fishermen, for coral reefs even. So this impact needs to be assessed by everybody. So that's the good impact that we can make, and we can help achieve this net zero without harming anybody, let's say. And then on the second question about the monopile and floating, I focused on monopile because these shallow waters we have in Brazil. It's true that in terms of how invasive the technology is, it seems that it's less invasive to just anchor a platform and that's it, rather than drilling or driving a monopile, right? But on the same side, the seabed is impacted by anything that touches it. So we can try and work and help and build some other solutions while we build. I'm trying to think some innovative, avoiding the fishing trolling, for instance, that is also invasive, or avoiding touching certain areas that can be of interest, environmental interest, like, yes, I said the coral reefs or any fauna, marine fauna that can be dramatically impacted by anything that invades, let's say, their habitat, right? So that's why we carry out geophys and geotech surveys, and we know completely the site, the locations specifically for each monopile before we do anything. And also we do this environmental impact assessment to really know if there's any marine mammal that will be impacted, any species like algae that cannot be touched, and that's their habitat. So that's the plan. Before we do anything, we really need to know the site and how we can impact positively and negatively the other users. I hope I
Thank you, Lara.
answered.
There is one last question by Pedro Guimarães that I will read here, but the last part of the question is a little bit difficult to answer because it depends on the Brazilian potential. But anyway, talking about logistics on installations and maintenance, how do you see the potential for new or converted specialized vessels to fulfill the operation demand? In our potential scenario, how big would be that fleet? That's the question, but I think it depends on the knowledge about our potential, of course.
Well, I think Robert covered this also about the fleet. Some of them, of the vessels, are repurposed. They are not just used for 20 years and thrown away. So they can be repurposed. We have, I mean, in an offshore wind, in the logistics of an offshore wind, we cover all of the sizes of the vessels, from 30 meters or 20 meters for a CTV, a tiny CTV that just do crew transfers, to the jackup vessel that installs the BTG. So it depends on the phase we are. It depends on the installation strategy, because sometimes it's faster to build a wind farm using 2 jackup vessels, but it's not cheaper. So it's a balance that you need to reach. That's for the construction phase, but you have this, well, cable laying, cable trenching, the jackup vessel, the offshore substation installation vessel that is huge. So for the construction vessel, it seems to be a bit crowded, but during the entire operation and pre-construction, it's not that big. It's just service vessels to maintain the entire wind farm. But normally we have a big SCADA system connected to our onshore control center. So we try to avoid those transfers and reduce the impact, let's say.
Okay.
Thank
you very much, Lara, for your very interesting talk and discussion. Thank you. I would like to invite now Danielle Schumacher from Equinox for his presentation. Danielle Schumacher is a project leader for renewables in Equinox with experience in offshore wind early phase projects internationally, business development, onshore solar farms construction, and oil and gas offshore projects. Danielle has a bachelor's degree in electrical engineering by Federal University of Rio de Janeiro and post-graduation courses on oil and gas and financing. Please, Danielle.
Thanks, Sejan. I hope that at this time you can see my presentation and listen to me clearly.
Yes.
Very good.
Fine.
Thank you. So, well, good morning or good afternoon to some of you watching. Thanks for the attention. Thanks to the organization for the invitation, and my greeting to other colleagues also presenting. Thanks for the presentations, Robert, Professor Suzuki, and Lara, very interesting. And greetings to Sandro, a known colleague from Abeolica, which we work together, and also Eduardo Wagner representing IBAMA. And who could imagine, right, that after a short time of IBAMA taking the first step for the regulations of offshore wind in Brazil, we would have almost 45 plus gigawatts under application. So we definitely gotta be cautious on what we desire, right? I guess that's a lot of demand on IBAMA, but that's for a good reason. That's for energy security planning for the country. And I'm glad to be here discussing such an important topic for the industry and for Brazil. So I'm Daniel, currently working with renewables business development in Equinor. And I would like to start with one number fact. As we speak, for instance, just for the next 60 minutes, 10,000 newborns will join us in the world. And that's approximately 250,000 every day, and will soon, by 2050, will be 10 billion people living in the world. And currently, almost 80% of the energy that we use comes from fossil fuels. At the same time, we know that we'll need even more. But the sources and this vision that the world will require more energy, even more than today, we need to change. And climate change is indeed the biggest challenge of our time. And that's why we see all across countries and investors and companies the net zero targets by 2050. That was well reminded by Professor as goal in Japan as well. And Equinor is not out of it. We launched the net zero emissions by 2050, and we want to be net zero by this time. And how to do it sustainably? It means definitely a complete shift in the energy systems, and that cannot start from night to day. By the time we reach 2050-ish, we must start now, because this transition takes time. Then this starts with a change in investments, and I'll show you right after here what we plan in the coming years in terms of offshore wind and renewables in general, to be a bit broader. So we plan to do a shift in investments. Equinor is a broad energy company that keeps producing oil and gas in the most sustainable way, reaching above average market-wise CO2 emissions results. But we intend and we plan to establish a strong position in renewables and be on the top quartile player of offshore wind. And that means investment. And just between 21 and 26, we plan to spend $23 billion US. That means almost half of our investments will be driven towards renewables. And in installed capacity, that would mean from 12 to 16 gigawatts installed by 2030. Only Equinor share, of course. Most of the projects these days are risk shared with one or two major investors. And in this sense, for offshore wind, more specifically, we have built so far a strong portfolio. And this is about assets under operation and assets under development and the future expanding pipeline to grow our position globally. In operations, Equinor does have practically 1 gigawatt already in production for bottom fixed. We've started the first floating offshore wind and even batteries feeding or saving storage from offshore wind. Our positions to be developed are mainly in the UK, in the US, and we also have a cluster in Poland, summing up close to 10 gigawatts under development, and that would include the biggest offshore wind project in the world, which is Dogger Bank, to which we are a partner. And we also expanding, and we intend to be a top player in floating, and we are expanding our position to UK, Ireland, France, Japan, and also USA. And we also have the first of its kind worldwide, which is a high wind campaign. It's offshore wind connected to oil and gas, and this is also part of the plan to decarbonize oil and gas production. High wind campaign is under construction already. It has been sanctioned and got this final investment decision last year, and we'll move on to feed 2 platforms. I will come back more in details to that afterwards. But I would just put one reflection here in terms of a capability. Those projects are far from being simple projects execution-wise and operation and maintenance as well, as they involve large structures, heavy liftings, repetition, and operations that would demand a lot of people as well. But safety, it has been for decades our first priority, and will remain as such as we move to renewables as well. Then we ask why offshore wind for Equinor. It's that we are basing our, we're leveraging from our experience of more than 5 decades in oil and gas, and the projects can be somehow compared in terms of complexity, as we see on the second picture. One of our wind turbines and towers being lifted. That's the type of heavy lifting that we are used to do. It also goes to the financial strength of such an investor that would attempt to become an offshore wind investor and operator. It's about risk management, and from the oil and gas industry, we are also able to unlock this and become profitable and generate affordable energy for all. We also, of course, have presence all across the globe, and especially in the clusters that we would like to continue working and expand the position moving towards renewables, which is the case of Brazil. And I'll mention specifically our perspectives in Brazil as well. Also, of course, as been presented by Robert, marine operations and maintenance, it's something fundamental, as we will rely on the attributes of offshore wind as a high capacity factor to really serve as a ballast to the systems that we integrate. And we need high capacity factors, we need high productivity and high efficiency, and marine operations and maintenance will be fundamental to make it the most efficient as possible, as we are also used to perform well in oil and gas clusters. And in the core of our company, we always had technology and innovation, and that won't be different. There will be even more need for technology and innovation, as we must make the costs of installation and operation of offshore wind to come down. And this will be only based in technology and innovation, in partnerships with the supply chain and the academia. So we are already doing that for decades. And that's why it's a fit for purpose to shift and to change our portfolio as we speak, and we're already doing so. And to show a few examples of such, I'd like to present like 3 models of projects that we are already either in operation or working on. And those are a floating offshore wind farm connected to the grid, a floating offshore wind oil and gas integrated, therefore connected to oil and gas fields to decarbonize their emissions in energy consumption, and bottom fixed standalone grid connected, which is the concept we have for Brazil, being the cheapest model, as Lara said, by using monopiles. That's the most common and spread technology now available. So this is the plan. But the first one is High Wind Scotland. It was the world's first floating wind park in operations in September 17, with installed capacity of 30 megawatts, powering 2,000 UK households. And since then, worth to mention, well, actually, since the demo, it was from 60 to 70% cost reduction, and this pace of cost reduction remains in floating offshore wind, and it's kind of substantially cost drop as we speak and as the years goes by, turning floating extremely competitive, especially in places where we cannot make bottom fixed turbines, as well explained by Professor Suzuki as well. The one in the middle is High Wind campaign. It comprehends 11 floating wind turbines in the Norwegian continental shelf, feeding with a total of 80 megawatts with concrete substructures and shared anchors. And that's decarbonizing the installation, the energy consumption of those 5 units. It's 2 fields connected, and we are saving 200,000 tons per year of CO2. That's quite relevant. Of course, that those types of projects are part of a major national plan, and therefore they would rely on supports to be enabled. But we do believe that with the targets, the world's targets in decarbonization and the needs that we have to face climate change, those type of models will be more recurrent, and we are already preparing ourselves for that and enabling this type of technology to the world. And then on the right examples, if I'm not wrong, this is Dudgeon, but the same type will be for Arkona and the other development projects in Poland. Is the simplest and the cheapest concepts with monopiles, bottom fixed wind turbines. So all in all, what I want to convey is the capability. It's important because these type of projects are complex, and it cannot go wrong because it incurs in safety for people, which must be a priority for one trying to make it happen, and that's the priority of Equinox. And then this has been like what I presented, what we have for international experience, but what are the perspectives for Brazil? Well, based on this international experience, we started studies for an offshore wind project in Brazil, and ended up out of the coasts of Rio and Espírito Santo with Aracatu, which is a project that comprehends 2 wind farms of 2 gigawatts installed capacity potential each. We have applied to IBAMA. We got the FCA, and we have an ongoing EIA. And we plan to do it along the next years. We do see Brazil as a potential very interesting area for offshore wind. We know that the availability and the regularity of the winds along the coast. And this brings an opportunity for the country, definitely, for a long-term energy planning, which can help to ensure energy security for a long time, given the extensive coast and barely, let's say, virtually unlimited technical potential for the country. In July, I think it's worth to mention, probably Sandro will come back to the history of wind in the country, but in July this year, only the onshore wind farms beat their generation records, and in a given day, if I'm not wrong, the 22nd, the entire Northeast region was fed by wind onshore. But this industry, it didn't become this big from night to day. It started 20 years ago, and in our worst crisis, energy crisis in 2001, in search of matrix diversification. And since that time, almost the entire, and by that time, almost the entire Brazilian system depended on hydro plants, which today correspond just to 50%. And yet, we may face dry seasons, and energy demand can go higher than the supply. So that's fundamental that we plan and that we use the sources of that we have in Brazil for a long-term thinking of our energy system. And wind has played an important role in the international diversification and could not be different from Brazil. That's why we do believe in this potential, and that we need further settlements to unlock this. But wind may represent one of the most promising sources for the years to come, for the decades to come. And the costs, of course, of onshore wind were way higher than they are today, which is basically the most competitive source. And that will not be different again from offshore wind. As we see, costs are dropping consistently and will remain dropping for the years to come. That means that after a batch of projects being unlocked, this will also play a big role, being competitive in time with other sources. But of course, new technology demands more efforts to be put in place. And as soon as we have supply chain in place and good competitiveness, this cost will also come down. And this will also, thinking in the long run, support decarbonizing potentially what is part of our matrix as well. And we can think about integration also with the oil and gas for the long run in the future. So the development of offshore wind is very important for Brazil, and the complex of Equinor is Aracatu, 2x2 out of Rio and Espírito Santo. And basically, as Professor Sejan in one of the questions put, that it's shallow waters, then we have water depth there between 15 and 30 meters, allowing for bottom fixed wind turbines, which are by now the cheapest technology. So, but having a plan as such is not
Danielle,
only what we need. We, despite the excellent resource base, we must have something else. And here, I would like to list the key elements to be considered to unlock this potential more in general. And then I will come more for the specificities of Brazil. And the main driver is predictability. We cannot consider this high level of investments without predictability, that this will be a commitment with the matrix, and that we have line of sight for new investments. It's not a one-off investment and not a one-stop shop that we do and leave behind. This is long-term value for the country that we will operate for decades to come. So predictability is important. Also, site allocations, development, either if it's decentralized or centralized models, both can work.
Danielle,
connection to the grid is fundamental as well, that we have line of sight and we have security of grid connection. We cannot play and prepare everything, and in the end, we don't have grid connection ensured. Incentive mechanisms and compensation schemes, well, detailed, because it goes back to the competitiveness and to the guarantee over investments, that we will have the right and the proper incentive mechanisms for that to happen. The development of supply chain and innovation support in terms of partnerships with universities, that's something we are already doing, because this is also long-term value, long-last value for the country. And supply chain development, of course, we cannot move, we cannot take one step without the partnership with our suppliers, and therefore they are ultimately important to proceed with offshore wind in the country. Well, and then to be a bit more specific to Brazil, I would mention that the use of the maritime space, including up to and beyond those 12 nautical miles, are important.
Danielle, please conclude.
Yes,
Danielle,
the definition. Yes, it's on the left. Some measurements, and the most important things, all in all, is that we collaborate, that we have this kind of arena and discussions to enable offshore wind in Brazil. So collaboration is also key, and we are keen to make it happen together with all of the players. Thank you all.
Thank you. Thank you very much, Daniel, for the very interesting presentation, especially the new project and the ARA2 project. Very challenging, very interesting. We are running out of time. Then I would like to ask you, Daniel, to have a look in the chat and Q&A questions, and if you can reply to them. Okay? Thank you very much.
Absolutely. Thank you.
Thank you. And now I would like to invite Sandro Yamamoto from Abeólica for his presentation. The presentation will be in Portuguese, okay? And o título é Energia Eólica no Brasil, Desafios e Perspectivas. Sandro é engenheiro eletricista pela Faculdade de Engenharia da USP, é especialista em comercialização de energia elétrica e regulação do setor, especialista em automação industrial, tem MBA em gestão empresarial pela FGV e atualmente é diretor técnico da Associação Brasileira de Energia Eólica, a Abeólica. Por favor, Sandro.
Obrigado, professor Seguin Stefan, pela apresentação. Agradeço a Sobena pelo convite, em nome da Associação Brasileira de Energia Eólica, da minha presidente, Elvia Ganon. Também parabenizo os palestrantes que me antecederam, que me ajudaram muito aqui no que eu vou falar agora. Até ajustei a apresentação aqui, professor, para pegar nos pontos principais sobre a energia eólica no Brasil, desafios e perspectivas. Okay? Bom, rapidamente, a Abeólica é uma associação que representa as empresas que atuam no setor eólico brasileiro, são cerca de 100 associados, e temos aí todo um trabalho com foco no fortalecimento e na sustentabilidade de toda a cadeia produtiva, com vários trabalhos em andamento, e coloco aqui a associação à disposição todos que estão nos assistindo. Depois, se quiserem mais detalhes sobre o nosso trabalho e temas técnicos, eu fico à disposição. Tá? Bom, muito bem. Já vimos nas apresentações anteriores o quanto a energia eólica offshore tem um potencial muito grande, o quanto ela tem crescido mundialmente. Neste slide, eu coloco aqui alguns pontos do Programa Global do Setor Eólico Offshore, do Conselho Mundial de Energia Eólica, o Global Wind Energy Council, onde ele coloca que as novas tecnologias têm provocado, né, uma queda de preços, isso a gente já viu, mais de 35 gigawatts instalados, né, offshore no mundo. Europa é a maior região, e vários países aí também crescendo com energia eólica offshore. Vimos o caso do Japão agora, muito interessante. Temos mais de 200 gigas, né, em nova capacidade até 2030. Não só na eólica onshore, mas na offshore também, a questão da Covid não provocará impactos significativos na perspectiva global. A tecnologia de turbinas flutuantes é uma oportunidade para o mercado, tem grandes expectativas, e também como a energia eólica offshore como um pilar aí para viabilização, diríamos assim, do hidrogênio, que chamamos de hidrogênio verde em algumas regiões, e a descarbonização mundial. Então, não é novidade o quanto que a energia eólica offshore tem de potencial e pode crescer muito, e o Brasil, sem dúvida nenhuma, é um local, né? Temos regiões com um ótimo potencial, e a gente acredita na associação que em breve já teremos novidades, notícias de viabilização de projetos eólicos offshore no Brasil. Tá? Esse é o slide que eu vou ficar mais tempo e que eu resolvi, que fiz até algumas alterações em função do que os colegas apresentaram anteriormente, e vou me ater aqui a algumas considerações sobre essa aprendizagem, a evolução tecnológica da energia eólica e o desafio para implementarmos a eólica offshore no Brasil. Porque, independente da tecnologia para a geração de energia elétrica, no Brasil, nós precisamos ter um desenvolvimento a ponto de conseguirmos uma competitividade e viabilizarmos através da venda da energia. Seja em um leilão, seja no mercado livre. Energia eólica onshore no Brasil, nós começamos a viabilizar através de um programa específico, depois tivemos os leilões, e hoje o mercado livre é responsável por tirarmos as eólicas onshore do papel. E no caso da eólica offshore, nós acreditamos que, através de um leilão, um produto específico, né? O que é o produto? O governo realiza leilões de energia, e um leilão ele pode compreender vários produtos: um produto solar, um produto para termoelétrica, um produto para eólica onshore e um produto para eólica offshore, em um modelo de contrato que seja compatível com as características da fonte. Então, os primeiros contratos para a energia eólica onshore, a entrega da energia era anual. E mesmo assim, se você não entregasse aquela quantidade de energia anualmente, você poderia obter a cessão de um outro gerador por um preço mais competitivo, e não tinha penalidades muito pesadas se você entregasse até menos 10% do contrato, e ainda tinha uma apuração quadrienal. E com isso, a eólica onshore se desenvolveu, conseguimos conhecer mais, os contratos começaram a ser cumpridos, e ao longo do tempo os contratos foram sendo aperfeiçoados, ficando, diríamos assim, mais rígidos. Então, para a eólica offshore, a gente acredita que um modelo de contrato, de leilão, 15, 20 anos, com uma entrega anual, seja um modelo para a gente começar a viabilizar os primeiros projetos. É claro que o mercado está muito dinâmico, e podemos ter surpresas com venda para o mercado livre, num modelo bem diferenciado. Mas quem sabe, através dessa fórmula que viabilizou a eólica onshore, a offshore tem aí seus primeiros projetos sendo viabilizados. Tá? Então, nesse slide aqui, pessoal, estou fazendo essa comparação e os possíveis encaminhamentos de soluções para a ajuda da viabilização da eólica offshore. Vimos que temos aí aerogeradores aí acima já de 10 megawatts sendo fabricados, então uma rápida evolução da característica técnica. Então, no Brasil, nós temos o processo de outorga na Agência Nacional de Energia Elétrica, em que o gerador ele pede outorga e muitas vezes, quando essa outorga é publicada, ele percebe que, num futuro próximo, ele vai precisar alterá-la, porque ele conseguiu viabilizar uma nova tecnologia, um novo modelo de aerogerador com condições diferentes. Então, a gente entende que para a eólica offshore, a gente podemos ter um caminho diferenciado também, ou até lá, ferramentas que ajudem o investidor a ter uma outorga e essa outorga já ter ali uma forma de alteração de característica técnica para não prejudicar o prazo, cronograma do investidor. E a evolução tecnológica também é importante por conta da logística. Hoje, um dos maiores desafios para a eólica onshore é o transporte dos equipamentos. Na maioria das nossas rodovias são de pista simples. Então, qual foi a solução? Como estamos conseguindo transportar os equipamentos? Nós pegamos cerca de 14 principais rotas que os equipamentos iam passar, contratamos um estudo extenso, com modelos de pás diferentes, modelos de equipamentos e de conjunto transportador, de conjunto caminhão e carreta diferenciados, quais seriam os impactos e quais seriam os pontos mais delicados na rota. Entregamos esses estudos para a DENIT, para a Polícia Rodoviária Federal, para o governo de estado, para estudarmos dentro dessas rotas as adequações que seriam necessárias para o futuro transporte do equipamento. E mesmo assim, em alguns locais, precisamos fazer a intervenção na rodovia para paralisar o equipamento, paralisar o tráfego para o equipamento passar. Então, para offshore, onde for necessário, nós já precisamos também efetuar esse trabalho de planejamento, de onde serão as rotas. Por mais que a usina seja offshore, nós teremos algum tráfego local ou mesmo entre estados dos componentes. Então, é fundamental esse planejamento da logística de transporte de equipamento. E, pegando um gancho com logística, já foi falado aqui também sobre linha de transmissão, transporte da energia, conexão dos parques eólicos. Este, sem dúvida nenhuma, é um ponto que nós precisamos ter atenção e temos soluções para ter a conexão do parque eólico offshore e a energia ser totalmente escoada. Para vocês terem como exemplo, praticamente todos os dias, ontem, anteontem, no começo deste mês, todos os dias nós temos o famoso curtailment, nós temos a restrição de geração eólica sendo feita todos os dias, e solar também, por conta da indisponibilidade ou da sobrecarga, ou não conseguimos, em linhas de transmissão, ou não conseguimos mandar energia entre regiões. O Nordeste brasileiro tem mandado energia para o Sudeste e Centro-Oeste, mas nós estamos batendo no limite de intercâmbio, então estamos vertendo vento, estamos vertendo energia eólica e vertendo energia solar. Isso com a atual capacidade instalada e o operador nacional do sistema implementando flexibilizações na transmissão. Se isso já está ocorrendo hoje, como fica se conectarmos 1, 2, 5, 10, mais 10 gigawatts ou mais 20 gigawatts no Nordeste brasileiro com energia eólica offshore? Tá? Então, nós temos que ter mais carga no Nordeste, como produção de hidrogênio, por exemplo, ampliarmos os sistemas de transmissão para intercâmbio e as soluções híbridas também. Tá? Então, como estamos resolvendo? Com estudos para justificar a necessidade de transmissão, implementando soluções onde a geração esteja próximo da carga no Nordeste e viabilizar, a gente consegue viabilizar a eólica offshore considerando esses pontos. A gente acredita que também algumas desonerações são possíveis para iniciar a eólica offshore, imposto de exportação. A gente tem agora, nós temos já o ex-tarifário para energia eólica para vários componentes, estamos batalhando por uma prorrogação desse ex-tarifário que vence agora em dezembro de 2021. temos um programa de incentivo que suspende PIS/COFINS para componentes também da cadeia produtiva, ICMS também para o gerador, na compra dos equipamentos, e desconto no uso da rede. Esse desconto do uso da rede, hoje já existe uma lei que extingue para as novas outorgas pedidas até começo do ano que vem, para a eólica offshore. Por enquanto, ela está nesse mesmo pacote, tá? A gente precisa ver como vai ficar depois aí da lei para a viabilidade para a eólica offshore, mas, na minha visão, acho difícil pleitearmos descontos na tarifa de uso do sistema após o início de vigência da perda do desconto com a lei que promoveu essa retirada para as fontes renováveis como um todo, não só para a eólica onshore ou offshore. Ok? Eu já falei sobre a restrição de geração, impacto de limitação, então é fundamental a expansão de linha de transmissão. Não vou tocar aqui na questão de licenciamento ambiental, é só um item aqui que nosso amigo Adriano do Ibama vai falar daqui a pouquinho, tá? Eólica onshore hoje tem muitos projetos sociais, paga arrendamento por uso da área, e sabemos que com a eólica sendo instalada no mar, nós precisamos dar continuidade, precisamos iniciar novos projetos, precisamos remunerar, né, federação, estado, município, e é importante nós buscarmos um equilíbrio para que essa remuneração pelo uso, né, da área do mar e seja equilibrada para que não prejudique a viabilização dos projetos. Tá? Então, são alguns pontos, pessoal, que eu queria colocar aqui para vocês, de desafios do onshore, foram superados, desafio para eólico offshore e como a gente pode superar. Okay? Na sequência da minha apresentação, aqui algumas notícias que mostram o quanto que o Brasil tem sido demandado, e vocês vão perceber na próxima apresentação da quantidade de projetos que estão em licenciamento ambiental, do interesse das empresas, e por isso a gente acredita que teremos uma abreviação do tempo. Os cronogramas serão mais rápidos e teremos parques eólicos offshore antes do que esperávamos. O potencial é imenso, com fatores de capacidade já estimados acima de 50% de fator de capacidade nos projetos, que mostra que o Brasil também é abençoado pelos seus ventos offshore, um país que tem várias fontes de energia e temos que aproveitar todas, e a própria EPE, na publicação do seu roadmap, mostrou o quanto que a gente tem potencial acima de 500, 600 gigawatts, batendo 700 na costa brasileira, do Nordeste, até um pouco indo para a região Norte, até chegar no Sudeste Centro-Oeste e região Sul. Isso se comprova se nós olharmos os projetos que estão em fase de licenciamento ambiental. Tá? Nós temos alguns estudos já publicados no Brasil, o roadmap da EPE, pelo Ministério de Minas e Energia, PNE 2050, 2030, o Going Global, Expanding Offshore Wind to Emerging Markets, pelo XMAP. Todos falam do potencial, dos desafios, da viabilização. O roadmap da EPE fala sobre logística também em outros itens, transmissão, o que nos dá mais material ainda para potencializarmos a nossa eólica no Brasil. Já temos, por conta do onshore, uma cadeia produtiva muito extensa, aqui local podemos aproveitar, tá? Então as empresas estão se preparando, conseguem ter dinâmica para atender o que for possível de componente local e aí buscar importar o que for necessário dentro de um equilíbrio aí nacional e internacional. Tá? Eu estou encaminhando para o final aqui da minha apresentação, temos muitos desafios, como eu comentei, tá? O modelo de regulação e o projeto de lei em tramitação, a gente acredita que serão aí pontos fundamentais, tá? Para dar maior até segurança para os investidores que hoje possuem aí já seus pedidos de requerimento de outorga e estão em licenciamento ambiental. O Mercado Livre também é uma chave aí para nós avançarmos. E tem um item que eu queria aqui fechar minha apresentação, é o guia para o investidor. Nada melhor que termos informações concentradas em alguns documentos para ajudar os investidores a desbravar um novo mercado. Então, pensando no Guia do Investidor, o Programa de Energia do Brasil, através de uma iniciativa do governo britânico com o governo brasileiro, elaborou um guia para o investidor. Ele foi entregue para o ministro de Minas e Energia recentemente. Este guia, ele contempla análise de impacto ambiental socioeconômico, análise do ambiente de negócios e infraestrutura, o quadro regulatório, tá? E além de outras informações. Nós, da Abiólica, estamos usando este guia para elaborar um outro documento que vai colocar mais detalhes para ajudar o investidor a avançar com energia eólica offshore no Brasil. Será um guia de investimento complementar, digamos assim, elaborado pela Abiólica com base no guia do investidor feito pelo BEP, pelo Programa de Energia do Brasil, em parceria com o governo britânico. Tá? Bom, pessoal, eu passei aqui por alguns desafios e perspectivas, tá? Fico à disposição para perguntas e o tempo é curto, acompanhem a Abiólica nas redes sociais, a gente tem muito trabalho sendo desenvolvido e querendo saber mais sobre eólica como um todo e offshore, eu fico à disposição aí posteriormente. Tá? Obrigado, professor, fico à disposição.
Obrigado, Sandro, pela apresentação muito clara e objetiva. Algumas perguntas estão surgindo aqui no Q&A, mas depois você pode dar uma olhada aí com calma. Eu queria te fazer uma pergunta, que é uma pergunta que surgiu numa das palestras anteriores, mas nós não tivemos tempo. Eu queria que você comentasse o porquê que está se caminhando para o mar. Aqui no Brasil, nós sempre temos essa questão, né? Eu, pelo menos, sempre me deparo com essa questão. Se o Brasil é um país tão amplo, por que ele vai produzir energia eólica no mar? Eu queria que você comentasse isso.
Perfeito, professor. Obrigado pela pergunta. Essa pergunta já vinha sendo feita aí no passado, porque, puxa, se eu tenho 300, 400 gigawatts de potencial eólico onshore, com preço competitivo, por que eu levo a eólica, então, para o mar? Né? Na visão da associação, professor, é óbvio que o custo da eólica offshore ela será maior que o onshore. Né? E nós não entendemos que ela vai para o mar porque ela quer tomar o espaço, né, da eólica onshore, ou mesmo de uma solar. Nós entendemos que a energia eólica offshore ela vem com um grande potencial para complementar a matriz elétrica do futuro. Porque o país possui uma média de consumo de energia elétrica residencial, uma média de consumo muito baixa. Né? Nós temos muito a desenvolver na nossa indústria, na nossa sociedade, e vamos precisar de muita energia elétrica. Infelizmente, passamos aí por algumas crises, né? Mas esse potencial ele precisa ser explorado para, em conjunto com as outras fontes, conseguir entregar a energia que o consumidor precisa. Então, nós temos eólica onshore produzindo muito na madrugada em uma região, e produzindo à tarde em outra região, da manhã até ali, final da tarde, com solar. E a eólica offshore ela vem para complementar essas curvas como um todo e entregar a energia como o consumidor precisa. Além disso, principalmente por questão do hidrogênio e indústria, que elas vão se instalar próximo ao litoral, aproveitando essa energia que será produzida, e a gente vai precisar da água por conta da eletrólise e hidrogênio, o mar, sem dúvida nenhuma, será o grande parceiro para o setor elétrico e energético, na forma da eólica offshore. Então, não é para tomar o local, e sim para uma complementação de curva de energia, de custos, e entregar essa cesta melhor para o consumidor. A diversificação, professor, é a chave para nós não passarmos o que estamos passando hoje, com bandeira vermelha, risco de escassez hídrica, risco de racionamento. Então, expandir, porque quando uma fonte ela tiver um período de baixa de geração, a outra fonte vai ter o seu aumento, elas se complementam e o consumidor não terá essa preocupação. Ok?
Muito obrigado, Sandro. Aqui nós estamos na Sociedade Brasileira de Engenharia Naval. É mais do que bem-vindo à produção offshore. Eu complementaria também a questão da escala, né? Com as novas turbinas, né, ficaria inexequível colocar uma turbina de 15 megawatts no onshore, em função das dimensões que se tem, as pás, etc. Enfim, eu acho que é um novo desenvolvimento. Muito obrigado pela sua apresentação e comentário.
Obrigado.
Ok, muito obrigado. Agora nós vamos para nosso último palestrante da sessão 1. Em seguida, nós vamos iniciar a sessão 2. Né? Então, eu convidaria o engenheiro Eduardo Wagner, do IBAMA, que vai falar sobre licenciamento ambiental de complexos eólicos offshore. O Eduardo Wagner é engenheiro civil, especialista em meio ambiente, é analista ambiental do IBAMA desde 2003, atua na diretoria de licenciamento ambiental há mais de 10 anos e atualmente chefia a divisão de energia nuclear, térmicas, eólicas e outras fontes alternativas. Tem vasta experiência em avaliação de impactos ambientais de empreendimentos de geração de energia, como usinas hidrelétricas, eólicas, fotovoltaicas, termoelétricas e nucleares. Agradeço a presença aí do Eduardo e coloco aí à disposição para a sua apresentação.
Bom dia, professor. Agradeço o convite, né, em nome do IBAMA, da gente poder participar aqui e apresentar. Agradeço a Sobena. Dou bom dia a todos os colegas panelistas aqui presentes também e a todos aqueles que estão nos assistindo. Eu vou compartilhar minha tela agora aqui com a minha apresentação. Estão vendo?
Estamos.
Deixa eu só colocar no modo apresentação aqui. Tá ok. Então, né, queria começar só dando uma contextualização aqui do que traz o IBAMA, né, para o licenciamento das eólicas
Eduardo, eu não sei por que pelo menos no que eu vejo, está cortando um pouco a tela. Eu não sei, Verônica, você confirma aí, o Alexandre?
Está cortando, sim.
Então, está aparecendo para mim um retângulo verde no meio da minha apresentação. Minha apresentação aparece normal, mas tem um retângulo verde, que provavelmente deve ser o recorte de vocês.
Se você colocar como a não ser como apresentação, será que eu acho que vai dar para a gente ver melhor?
Realmente, ela está dentro da... Estranho isso. Está conseguindo ver assim?
Agora
sim.
Estamos.
Está vendo só a tela do PowerPoint, né?
Agora, tenta colocar modo apresentação para ver se volta a mesma coisa.
Cortou de novo, não cortou?
Sim.
Cortou. É melhor você manter, então, sem estar modo apresentação.
Deixa eu só ver uma coisa aqui, só um minuto. Aí. Vou aumentar aqui. Agora tá ok?
Agora eu acho que tá ok, tá ok. Tá ok.
Então, consegui descobrir o que era aqui.
Vamos em frente, então.
Vamos lá. Uma contextualização, né, do porquê que é o IBAMA que faz o licenciamento ambiental de eólicas offshore, né? Os complexos, né, no total, na definição da lei, né, do decreto 8.437, que regulamentou a Lei Complementar 140 lá de 2011, né, que faz a definição do que é competência de cada ente da União, né, dentro no escopo do licenciamento ambiental, seja a União, seja o Estado ou os municípios, ficou definido, né, lá no seu artigo 3º, lá no item 7, no C, que diz que as usinas eólicas, no caso de empreendimentos e atividades offshore e na zona de transição terra-mar, seriam de competência da União. Então, a competência da União, o licenciamento ambiental é realizado através do IBAMA, né? Isso quer dizer o quê? Que única e exclusivamente é o IBAMA que licencia essa tipologia de empreendimentos hoje aqui no Brasil com base na regulamentação. Né? O IBAMA age na questão do licenciamento ambiental basicamente dentro única e exclusivamente da ótica ambiental, né? A gente avalia os aspectos ambientais da inserção desse empreendimento proposto em dada área, né? E através disso das análises a gente verifica a viabilidade ambiental ou não dessa inserção proposta, né? Então, isso posto, né, cabe destacar que, como já foi dito aqui em outras apresentações, há outras autorizações a serem obtidas em outros órgãos, tais como, né, ANEEL, SPU e Marinha, né? Hoje, inexiste, né, um arcabouço técnico legal nacional sobre o assunto, o que pode gerar muito conflito de interesse, né, e um excesso de discricionalidade técnica nas análises, né? Fazendo um contexto aqui, antes de eu adentrar especificamente na questão das eólicas offshore, falando do como que se dá o processo do licenciamento ambiental de uma maneira rápida aqui. Basicamente, esses empreendimentos que possam causar grandes impactos, né, como o caso de eólicas offshore, desses grandes complexos que já temos propostos hoje, nós seguimos um modelo trifásico, né, que é através da licença prévia, a licença de instalação e a licença de operação, né? Como o nome propriamente diz, né, a licença prévia ela é uma das licenças mais importantes, porque ela analisa, né, todo o estudo de impacto ambiental que deve ser realizado para o empreendimento, e ele atesta ou não a sua viabilidade ambiental da inserção, né, do empreendimento, considerando a sua concepção e a localização. Um segundo passo seria a licença de instalação, que ela autoriza, propriamente dita, né, a instalação do empreendimento, você começar as suas obras, né, e fazer todas as intervenções necessárias na área. E a partir daí, com base todas as informações, né, dos planos e programas que foram executados ao longo da licença de instalação, você consegue chegar na licença de operação. Fazendo um detalhamento maior aqui, né, a licença prévia, basicamente, ela testa a viabilidade ambiental, como eu disse, né, e o rito dela é mais ou menos se abrir uma ficha de caracterização ambiental junto ao IBAMA, que você vai trazer as informações básicas do empreendimento, né, do objeto a ser licenciado, né, com todas as suas estruturas acessórias, e com os shape files, né, dos polígonos, né, e das linhas de transmissão e todas as intervenções que são necessárias ali. A partir daí a gente faz uma análise de competência, com uma análise de enquadramento, que se segue da emissão desse termo de referência, que eu vou falar daqui a pouco, né, um pouco mais, que eu acho que é a parte mais interessante aqui. Então, assim, dentro desse processo, até você chegar a dizer a viabilidade ou não do empreendimento, você passa por algumas análises, né, como para emissão da autorização de coleta e captura, né, e monitoramento de fauna, né, que é essa BIO. Tem comunicação com órgãos intervenientes, no caso, no âmbito da portaria interministerial número 60, que se dá com o ICMBio, com o FUNAI, com o INCRA e com o Ministério da Saúde, dado, né, a localização do empreendimento. Isso depende muito dessa questão locacional. É realizada uma audiência pública, na qual se apresenta o empreendimento para a população, né, e onde você se colhe muitas informações. Nós já realizamos uma audiência pública no município de Caucaia, para um dos empreendimentos que já aplicaram, né, para o licenciamento ambiental aqui. Após isso, é feita efetivamente a análise de mérito do estudo de impacto ambiental, né, define-se também a compensação ambiental, que vai ser executada somente lá na frente, e emissão ou não da licença prévia, né? Essa licença prévia ela tem uma validade de até 5 anos. Hoje, dentro dos modelos de leilão da ANEEL, né, é requerido, né, as tipologias já estabelecidas, como as eólicas onshore, hidrelétricas ou termoelétricas, que você tem a licença prévia para concorrer a leilões, né, de energia. Após isso, né, nós temos a licença de instalação, que ela autoriza efetivamente, né, a instalação do empreendimento, de acordo com essas especificações constantes nos planos e programas ambientais previamente aprovados, e ela se dá através do que a gente aqui está plano básico ambiental, mas hoje a gente já usa uma nomenclatura um pouquinho diferente, a gente chama plano de gestão ambiental, né, onde ele traz os programas com os seus planos que vão ser executados na área, né, seja monitoramento da biota aquática, monitoramento hidrossedimentológico, monitoramento do comportamento marinho, né, de mamíferos, enfim, é uma vasta gama de planos e programas que devem ser executados no âmbito desse processo do licenciamento ambiental, né, e as eventuais condicionantes ambientais da licença prévia que teria. Com base em toda essa análise, né, e os relatórios de monitoramento da instalação, você pode né, declarar que está apto para passar para um próximo passo, né, que é efetivamente a instalação, e esse prazo máximo dessa licença, ela tem até 6 anos. Em se avaliando tudo ok, né, que transcorreu tudo conforme o programado, né, nos planos e programas ambientais, você passa para a licença de operação, né, que ela vai autorizar o empreendimento a funcionar em si, né, começar a gerar energia e a sua transmissão. Então, ela é com base também em toda a avaliação daquilo que foi executado no âmbito da licença de instalação e do que foi proposto para a licença de operação, você consegue chegar à licença de operação, que também vai conter programas ambientais a serem executados na operação, né, em diversos programas de operação, como, por exemplo, resgate de fauna afetada, monitoramento da fauna, né, as interações com possíveis usos múltiplos da área, como, por exemplo, dos pescadores, né, que aqui no Brasil a gente tem casos de pescadores que fazem essa pesca artesanal a 50, 80 quilômetros da costa, né, com pequenos barquinhos, né, ou até mesmo jangadas, dependendo da região, né, e essa licença de operação, o prazo dela pode variar de 4 a 10 anos. Tá? Então, em síntese, né, com base nos estudos do levantamento contidos no estudo de impacto ambiental, o IBAMA avalia, né, a viabilidade da inserção desse empreendimento dessa área proposta. Né? Com isso, definindo todas as suas condições de implantação, ele pode conceder a licença de instalação e determinar como que os impactos, né, eles vão ser compensados, mitigados, né, e evitados através desses programas e planos ambientais. A partir daí, você consegue passar para a fase de operação, né, também por meio dos planos e programas ambientais do empreendimento. E o acompanhamento por parte do IBAMA continua por toda a vida do empreendimento até o seu descomissionamento ao fim da sua vida útil. Né? Esse descomissionamento é até um dos itens solicitados, né, que seja feito os apontamentos de como que se dariam, né, no âmbito do estudo de impacto ambiental. Cabe destacar, sim, né, que o processo do licenciamento ambiental não é algo fixo, estático, né? O processo de licenciamento ambiental ele é um processo dinâmico, né? Desde da sua proposta na abertura do processo, em que você vai tendo o IBAMA solicita informações, essas informações são, né, trazidas ao IBAMA e você retroalimenta os estudos, né, e você vai fazendo ajustes e modificações, né, também como no caso de propostas, né, feitas pelo empreendedor com base, ele vai fazendo os seus refinamentos nos estudos, né, com o andar do empreendimento. Então, assim, é uma coisa que eu gosto muito de deixar claro, né, que não é algo estático, né, é sempre muito dinâmico esse processo. E esse termo de referência que o IBAMA, né, publicou no ano passado, em 2020, acho que cabe fazer uma pequena contextualização, né, os primeiros processos de pedidos de licenciamento ambiental de eólicas offshore no IBAMA começou por volta de 2016, né, sendo que a gente não havia nenhuma tipologia, não há ainda, né, instalada, mas os primeiros processos ali, o IBAMA não tinha, né, nenhum conhecimento, era algo novo, não só para o IBAMA, como em todo o Brasil, a instalação dessa tipologia aqui, né? Então, a gente entendeu que a gente precisava fazer um estudo em que capacitasse as equipes técnicas e o próprio IBAMA para poder entender como que se funciona e recepcionar esses projetos de maneira adequada, né? De uma forma que a gente pudesse dar segurança para quem resolvesse investir em tal tipologia de geração de energia aqui e também para a equipe técnica fazer suas análises, né? Então, a gente, o IBAMA, né, nosso corpo técnico lá junto na DNF, né, que é a divisão do qual eu chefio, propôs um projeto junto ao um programa de financiamento para projetos de estudos para energias renováveis, que chama Diálogos Setoriais, que é da União Europeia, né? E o nosso projeto foi aprovado, em que a gente conseguiu um financiamento que a gente pudesse contratar alguns técnicos e produzir alguns produtos, né, nesse sentido, e também realizar alguns eventos. Então, o primeiro dele foi fazer um diagnóstico, né, dos modelos regulatórios que hoje estão estabelecidos, né, no planejamento ambiental, na avaliação de impacto ambiental de complexos offshore em diferentes países da Europa, né? Porque não faz sentido a gente tentar criar rodas, sendo que já tem todo um conhecimento ali que a gente poderia beber da fonte e adaptar ao Brasil. Então, nós contratamos um técnico que fez todo esse levantamento, basicamente da legislação europeia, mesmo sendo da União Europeia, tendo o Brexit, a gente conseguiu incluir o Reino Unido, então foi feito com base nas informações do Reino Unido, da Bélgica, da Alemanha, né, e de Portugal, se eu não me engano, e eu acho que ainda tem algumas informações da Noruega. E com base nisso, né, a gente começou a definir o escopo desse termo de referência e a gente propôs a realização de um workshop aqui internacional em junho de 2019 no IBAMA, que a gente conseguiu trazer técnicos desses países que eu mencionei anteriormente, né, tanto que trabalhavam com o licenciamento ambiental, como outras áreas, né, como, por exemplo, técnicos que trabalharam na parte de instalação e têm conhecimento dos impactos dessa fase do empreendimento. Então, nós trouxemos eles aqui e demos mais ou menos os temas que nós queríamos abordar. Junto com eles, nós convidamos também diversas outras entidades, né? Trouxemos técnicos de universidades, técnicos do CEMAV, né? Do ICMBio, um centro especializados em aves, né? Marinhas. E a partir disso, nós desenhamos uma proposta de referência e a gente mandou novamente para esses técnicos da Europa que tiveram aqui poder fazer as críticas, né? E a partir disso nós definimos um escopo do que seria o nosso termo de referência, né? Nós estruturamos e colocamos em consulta pública no início do ano passado. E essa consulta pública, ela ficou durante 3 ou 4 meses, onde nós recebemos cerca de 130 colaborações, né, nessa consulta pública, sugestões e críticas, da qual nós avaliamos, pegamos muitos pontos ali que eram bastante pertinentes, e a partir disso a gente estruturamos o termo de referência e botamos ele para, efetivamente, né, publicamos ele em novembro do ano passado. Só para contextualizar assim, até novembro do ano passado, o IBAMA tinha, ao todo, 7 empreendimentos com processo de licenciamento aberto para eólicas offshore. A partir do momento em que nós disponibilizamos esse termo de referência, que ele é muito bem estruturado e que ele traz até referências, esses números de processo eles passaram para 23, atualizado até a semana retrasada, que já estão abertos. Ou seja, o termo de referência trouxe uma segurança, né, para quem já pretende iniciar esses processos aqui. E esse termo de referência, né, ele tem basicamente o objetivo de determinar diretrizes e critérios técnicos, né, que deverão fundamentar a elaboração do estudo de impacto ambiental. Nós fazemos várias informações do que é pedido, como, por exemplo, distanciamento da costa, as informações relativas à fauna, flora e o meio físico e aspectos do meio socioeconômico, né, estão todos muito bem pontuados. Muito deles, por se tratar de uma tipologia nova aqui no Brasil, nós damos exemplos do que se espera que seja feito, né, diferente de outros termos de referência que a gente tem, que são muito sucintos, né? Então, esse é mais robusto e mais completo no que pede. Ele é basicamente aplicável aos processos de significativo impacto ambiental, ou seja, esses grandes complexos eólicos, né, que pode trazer um impacto significativo ao local que está sendo proposto, né, e dentro da proposta da regulamentação que a gente foi necessário fazer com base na Lei de Liberdade Econômica, o IBAMA publicou a portaria 78 de 2021, em que ela traz todos os seus empreendimentos que são passíveis de licenciamento, né, especificamente da diretoria de licenciamento ambiental, pois a gente tem outras diretorias que são abordadas ali também, mas lá nós estabelecemos que, a priori, né, dado o conhecimento que a gente tem hoje, isso pode mudar ao longo do tempo, que empreendimentos com até 2 turbinas, né, ou instalados sobre plataformas já existentes e licenciadas, poderão demandar um estudo ambiental simplificado para sua viabilidade, né, ali. Isto posto, né, hoje é o que nós temos aqui, basicamente, né, os empreendimentos com processo de licenciamento aberto, que juntou ao IBAMA. Eu acho que esse mapa aqui, ele ainda é o do mês passado, ele deve conter apenas 20 ou 21 empreendimentos, nós temos mais 2 novos propostos. Ele fica claro alguns clusters, né, de áreas mais propícias, né, para a inserção desses empreendimentos. Se você vê mais notadamente essa costa do Ceará e do Rio Grande do Norte, e essa região na divisa do Espírito Santo com o Rio de Janeiro, né? E aí você pode ver aqui que já tem algum problema, né, que o IBAMA identifica, que é a sobreposição de áreas, né, porque hoje a gente não tem uma regulamentação quanto a isso. O entendimento do IBAMA é baseado na legislação, não há nenhuma legislação que bote que o IBAMA deva fazer, dizer, né, quem tem o direito ao uso dessa área, né, ao IBAMA cabe apenas a avaliação dos impactos ambientais e a determinação da viabilidade ambiental ou não desses empreendimentos. Então, precisa-se ainda haver umas outras regulamentações em outros entes, né, que promovam, né, a adequação da instalação desses empreendimentos. Nós já chegamos a fazer algumas reuniões com a ANEEL, né, e onde até foi proposto que uma reunião futura entre a ANEEL, IBAMA e Secretaria do Patrimônio da União, para poder discutir esses pontos e entender. Eu sei que a ANEEL está trabalhando numa regulamentação relativa a isso, até um projeto de lei também, mas enfim, nós que temos tido reuniões com esses empreendedores desses empreendimentos, muitos europeus, né, a grande maioria que vem tratando aqui de empresas da Europa, eles demonstram assim, muita preocupação com relação a isso, porque você investir um grande montante de dinheiro para você fazer um estudo de impacto em uma área que pode ter uma sobreposição com outro e ainda não há definição quem tem o direito ao uso, você tem uma certa insegurança envolvida aí, né, nesse ponto. E até mesmo para o IBAMA, né, porque se eu recebo 2 EIAs de áreas sobrepostas, quem vai ter o direito ao ter a licença prévia? Poderia dizer, olha, vai ser o que abriu o processo primeiro. Mas e se o que abriu o processo primeiro, eu peço complementações aos estudos, e o que abriu o processo em um segundo momento não tem complementação aos estudos, e eu termino a análise de viabilidade dele primeiro? Então, assim, tem alguns pontos que ainda são nebulosos em relação a isso, que precisam ser trabalhados, né, para poder ter toda essa segurança, né, para a instalação desses empreendimentos e na análise de todos os entes envolvidos. Isso aqui posto, né, são as áreas de instalação dele. Aqui eu tenho, basicamente, é uma definição de todos esses empreendimentos. Se você ver aqui num resumo, que eu acho que é interessante, que até o momento são cerca de 3.500 aerogeradores propostos com uma capacidade de quase 47 GB de potência instalada. Eu já posso falar que esse mapa realmente ele está defasado da última atualização, em que esse 47 GB já deve estar chegando a 50 GB de empreendimentos de energia a ser gerada propostas, né, para a costa brasileira hoje. Cabe destacar também que há alguns pontos que a gente vem discutindo com alguns empreendedores, como, por exemplo, se voltar o slide anterior, você pode verificar que há essa alocação dos geradores propostos, e muito se utiliza na Europa o que eles chamam de conceito envelope, né? Que é você fazer o licenciamento do polígono como um todo, com diversas opções de instalação, por exemplo, fundação monopile ou fundação flutuante ou outros tipos. Você avalia as possibilidades que podem ter, e você faz todo o levantamento ambiental para as diferentes possibilidades, 2 ou 3 possibilidades que tenha para cada coisa, e você avalia o impacto ambiental do pior caso. E com isso, você consegue definir o quê? Como mostrou em outras apresentações hoje, se você faz uma instalação, hoje você tem disponível uma turbina de 10 megawatts, né, 12 megawatts, quando da realidade da instalação de um empreendimento desse lá no futuro, daqui 7, 8, 10 anos, você pode ter 15, 20 mega, mas você já teria um licenciamento que foi abordado isso hoje, e não você teria que refazer uma retificação da licença prévia lá na frente, né? Então você teria um ganho nisso aqui, tanto para o projeto quanto para a avaliação por parte do IBAMA. Então, essa é uma das modificações que eu mostro, assim, que ela não consta do nosso termo de referência, e é uma coisa que já vem sendo avaliada, que foi pedido por dois empreendimentos diferentes, em que o IBAMA já pensa em readequar esse termo de referência nosso. Bem, acho que basicamente era essa. A gente tem muita informação para passar, mas para caber no tempo aqui, e ter uma ideia do que é o licenciamento ambiental, do que são os empreendimentos que a gente tem abertos hoje junto ao IBAMA. Então, eu agradeço aqui novamente por poder participar, e passo a palavra novamente ao professor. Só antes de terminar, quem tiver interesse, no site do IBAMA, se você for lá, ibama.gov.br/LAF, né, LAF, de Licenciamento Ambiental Federal, na aba Consultas, você tem aqui todas as nossas publicações, o termo de referência, esse mapa, e um KMZ atualizado com todos os empreendimentos já abertos aqui junto ao IBAMA. Obrigado.
Obrigado, Eduardo, pela sua participação, muito instrutiva e clara. O termo de referência do IBAMA é um marco aí para a indústria eólica offshore. Eu acho que isso vai progredir e ajudar nos investimentos. Eu queria só fazer um comentário antes da gente fechar. Possivelmente tem outras questões, o assunto é muito rico, e eu pediria depois para você ver no nosso questões e respostas, e, se possível, responder a audiência aí que está fazendo as perguntas. Mas uma questão que eu levanto, Eduardo, é um ponto que você mencionou no fim da sua palestra, sobre eventuais superposições. Eu, em função da nossa experiência na parte de óleo e gás, eu acho que seria muito interessante poder analisar o modelo da ANP, possivelmente vocês já estão olhando isso, né? Onde os blocos são definidos e as empresas, né, disputam o bloco, e não elas decidem sobre o seu próprio bloco, né? Eu acho que isso é algo extremamente importante para a gente dar prosseguimento a esse esforço do IBAMA. Outro assunto que eu queria só anunciar aqui: está em progresso no Ministério de Ciência e Tecnologia um edital para seleção de uma OS que vai ser responsável pela pesquisa oceânica. E um dos temas relevantes é a energia dos oceanos. E, certamente, a comunidade científica estará, né, no âmbito desse instituto, podendo dar subsídios muito importantes para essas zonas que deveriam ser protegidas, sobre questões ligadas ao espaço oceânico. Eu acho que todas essas questões são muito relevantes, e a interação com o IBAMA será muito bem-vinda aí no futuro. Te agradeço novamente, muito obrigado. Eu vou encerrar. Obrigado pela sua participação. eu vou encerrar a sessão 1 desse workshop, mas antes de passar para o meu colega, professor Alexandre Simos, gostaria de agradecer a audiência que esteve nessa sessão 1. Eu acho que muita coisa interessante virá a seguir aí na sessão 2, e aproveitar também para agradecer os patrocinadores, né? A Ocean Pack, que é o patrocinador master, e a DNV e Bureau Veritas, que são patrocinadores prata.